All right, exercise 4.2, letter I, we're going to start with. So they tell us x plus 3 absolute is greater than 0. Right, so remember we have two different conditions. Firstly, if x plus 3 is greater than or equal to 0, then x must be greater than or equal to negative 3. And that would give us x plus 3 is greater than 0, therefore x is greater than negative 3. However, if x plus 3 was less than 0, then we'd have minus x minus 3 greater than 0. So minus x is greater than 3, therefore x is less than negative 3. Right, so if you compare these two solutions, this one is saying that x is everything greater than negative 3. This one's saying x is everything less than negative 3. So basically, any number is a solution except negative 3. So the way that we would write that is that x is an element of real numbers, but x cannot equal negative 3. Okay, but to revisit this example, we are told that there is a shortcut. Okay, and that shortcut is that if and the shortcut is this. All right, firstly, we've got two different conditions. First of all, if a, b, and c are constants, okay, so a represents the coefficient of x, b represents the constant, and c represents the value on the other side here. So if they are constants and c is greater than or equal to 0, in other words, this can't be a negative to apply this rule, then this absolute of ax plus b less than or equal to c is negative c less than or equal to ax plus b, negative less than or equal to c. So in other words, if the absolute is less than whatever the constant is on the right-hand side, then we would have the negative constant there, the positive constant there, and the middle value here, and you would solve accordingly. Okay, if, however, a, b, and c are constants and c is greater than 0, same as this, then the absolute of ax plus b greater than or equal to c is ax plus b is less than or equal to negative c, or ax plus b is greater than or equal to positive c. Okay, so if you look at this example we've just done, it matches the second condition. Okay, because we've got that the absolute is greater than our particular constant. So in other words, we can straight away go to saying that ax plus b, in this case x plus 3, is less than, not less than or equal to, because in this particular problem it's just greater than. Okay, so we're applying this rule now. Negative the constant, in this case obviously negative 0 is 0. And then for the positive side for this one, we would say that x plus 3 is greater than 0. So x less than negative 3 or x greater than negative 3. And you see that gives us the same solutions. Okay, so in this case, x is an element of all real numbers except negative 3, which is not included. All right, for j, there's no working out, there's no solution, because we have an absolute on the left, and we can never have an absolute that is less than 0. So therefore, there's no solution. And in fact, I'm going to cut to L as well now, because in L, we have a similar situation. So we have the absolute of 4 minus x is less than or equal to 0. Now, it can never be less than 0, but it can be equal to 0. So the only solution that would make the left-hand side equal to 0 is when x equals 4. Right, so that's our only solution there. All right, for k, let's look at the long version. So if 3x plus 9 is positive, then we get minus 9 is greater than or equal to 0, and we can solve accordingly. So 3x is greater than or equal to 9, and therefore x is greater than or equal to 3. Okay, so that's our first solution. But if 3x minus 9 is negative, then we get negative 3x plus 9 is greater than or equal to 0. Right, so now in this case, minus 3x, we get negative 9 on the right-hand side. Now we're going to divide through by negative 3 to get x is less than or equal to positive 3. Remember, change the direction of the inequality when you divide by a negative. Okay, so that's the other solution. So now if you look at the two solutions, this one is telling us that x can be everything that is 3 and above, and this is telling us that x is everything that is 3 and below. All right, so effectively that means that x is an element of any real number. Okay, remember absolute values we only deal with in the real number system, not in the complex number system. All right, but now I'm going to show you how to do it using that shortcut that I explained on the previous slide. So if I let me just delete all of this. Okay, so now in this example, we've got another greater than. So if you look back on the previous slide when I spoke about A, B, and C, etc., if we have the absolute that's greater than your constant, then it means that it's the inside of the absolute, 3x minus 9 is less than or equal to negative 0, or just 0, obviously, in this case. And this time I've used the negative or equal because that's what's in the original question. All right? Or we have the absolute 3x minus 9, which is greater than or equal to 0. And then you see if you solve this, you get the same solutions. Right, so that becomes positive. X is less than or equal to 3. Or on this side, 3x is greater than or equal to 9. So x is greater than or equal to 3. So again, x is an element of all real numbers.